So we have negative x squared y divided by 16xy squared. So what I like to do when trying to get this down to its simplest forms is use prime factorization. Prime factorization to me just seems to be an easier way to minimize mistakes. So that's the route that I go. So we're going to start by looking at our numbers first. So we have a negative 8, and we're going to find the factors of negative 8, and we're going to put it in prime numbers. Okay? So we have a negative 4 times 2 gives us a negative 8. But we're going to reduce this further, so we have a negative 2 times 2 times 2. We're going to bring down that 2. So we know a negative 2 times 2 gives us a negative 4, and a negative 4 times 2 gives us a negative 8. But I'm going to go one step further with this negative. I'm going to do a negative 1 times 2, and I'm going to bring down these 2's. It doesn't change the value because we have a negative 1 times 2 still gives us a negative 2. A negative 2 times 2 gives us a negative 4, and a negative 4 times 2 gives us a negative 8. Okay, so we have 16. We're going to go 8 times 2 is 16. We're going to break 8 down to 4 times 2. Bring this 2 down. And then 2 times 2 gives us 4. Times 2 gives us 8. And times 2 gives us 16. Okay? So now we see that at the very bottom, all we have left are prime numbers, hence the name prime factorization. We are factoring out these numbers to where we only have prime numbers. So we're going to add this factorization in our rational expression. So we have a negative 1 times 2 times 2 times 2 times x squared, which is x times x and y. Okay, and we have 16, which is 2 times 2 times 2 times 2 times 1x, and y squared is 2y. So now at this part of our problem, we are going to cancel out, but we're going to cancel out in pairs, meaning that we can only cancel what's on the top if we have the same thing that's on the bottom. So we have this 2 that we can cancel and this 2 at the bottom. These 2 cancel and these 2 cancels. We aren't going to cancel this 2 at the bottom because there aren't any 2's left in our numerator. So we're going to leave that be. We have 2 x's. We have an x at the numerator, an x in the denominator. And we have a y at the top and a y at the bottom. So now we have to see what we have left. We have a negative 1 times x. And we also have at the bottom 2 times y. Now a negative 1 times x is a negative x, and 2 times y is 2y. Because we don't have anything that can cancel, we don't have any more pairs, this is our final answer. Okay, so now we're working with 5x squared z cubed all over x z to the 4th. And what we're going to do is we're going to simplify this rational expression to its simplest form, or to its lowest terms. So what we're going to do is we're going to write out everything that we have that's present and see what's left to see what we can cancel. So we have 5 here. We have 2 x's. Okay. Z cubed is 3 z's. 1, 2, 3. All over 1x times 4 z's. So what we've done is we've basically just broken this down so that we can see everything that we have present. This also is known as prime factorization, meaning that we're going to take our numerical numbers and we're going to get them down to only prime numbers. And also we're going to write out how many variables we have present. Now in this process, well, at this point of the problem, we're going to cancel out in pairs. Okay, so we have, change the color. So we have an X here, an X here. We notice that we don't have any more X's in the bottom. So we're gonna leave this X where it is. So we're gonna cancel those two Z's, these two, and these two. Okay, so let's see what all we have left. We have a 5, we have an X, and we have a Z. Now looking at this, we don't have any Z's up top, we don't have any X's on the bottom, and 5 is the only numerical number that we have. So this right here is our answer in its lowest terms. So we have a rational expression that we need to simplify to its lowest terms. We have 3xy cubed minus 27xy all over 6xy squared plus 6xy minus 72x. So the first thing that I see by looking at this, I see that 3 evenly goes into negative 27 and 6 evenly goes into a negative 72. Also, I'm noticing that in the numerator, we have at least one X and at least one Y in the first and in the second term. Also, the same is true for our denominator. We have at least one X in each of these terms and at least one Y in 2 of these terms, which lets me know that I can pull out the GCF to simplify this rational expression. So we're going to pull a 3 out in our numerator, and we have at least one X in the first term and in the second term. So I'm going to add that, and we have at least one Y in both terms. So I'm going to include the Y. Now we open our parentheses. So at this point of our problem, we need to find out what is it that we can put inside this parentheses that will multiply by 3xy to give us our numerator. Okay, so because we have a 3 in our numerator, we don't have to include the 3. Because we have an X, we don't have to include the X. We have one Y here and we have Y cubed. So we're going to say Y cubed minus Y leaves us with Y squared. And we know that when we multiply this back out, 1 plus 2 gives us 3. So that part is correct. We're going to bring down our operation sign, and we know that we have 3 here and we have a negative 27. So what times 3 gives us a negative 27? 9. Okay. So we can now close it. We don't have to add any X's or any Y's because the X's and the Y's are already accounted for in our GCF. So now we're going to start with our denominator. So we know that 6 goes evenly into 6 and into a negative 72. So we're going to pull out the 6. And we have at least one X in each of our terms. So we're going to put the X. And because this third term in our denominator does not have a Y, we're not going to include Y in our GCF. Anything that we include in our GCF has to be in each one of our terms. And because Y isn't in the last one, we're going to go ahead and open up our parentheses. So in our first term, we have the 6 that's accounted for. We have that X that's accounted for, but we have this Y squared here that's left over. So we're going to start with Y squared, and we're going to bring down this addition sign. So we have 6X, and we have here 6XY. The only thing that's not accounted for is the Y. And we're going to bring down this negative sign. And we know that 6 times a negative 12 gives us a negative 72. And because this X is here, and we have an X in our last term, that's all we need in our parentheses. Okay? So now we see that we have the difference of squares here, and we also see that we can factor this out. It is important to factor as much as you can so that we can see what we can cancel out so that we can get this to its lowest terms. Okay, so we know that the difference of squares, this is going to be y minus 3, y plus 3. And if we expand this out, we're going to get y squared minus 9. Okay, so now we're going to deal with this polynomial, y squared plus y minus 12. So we're going to go ahead and bring down our 6x, but this tells us that we need two numbers that multiply to give us a negative 12, but add together to give us y. So we know that 4 times 3 gives us 12, and 4 minus 3 gives us 1. But we need to switch those signs around so that we get a negative 12, but also get a positive 1 when we add it together. So we're going to go with a negative 3 and a positive 4. We know that negative 3 plus 4 gives us a positive 1, and negative 3 times 4 gives us a negative 12. So that's where the factors that we're going to use. We have y minus 3, and we have y plus 4. So we can start simplifying now. So here we have 3 goes into 3 one time, 3 goes into 6 2 times. Here's an x, and that's an x. So we can cancel those out. We also see that we have a y minus 3 here and a y minus 3 here. Okay, so now we see what all we have left. We have 1 times y plus 3, and we have 2 times y plus 4, which equals y plus 3 divided by 2y plus 4. And because we know that we can't cancel with the y and the 2, and y plus 3 and y plus 4 can't be canceled, this is going to be our final answer. So now we have x minus 2 over x cubed minus 8. So I can look at this now and tell that x cubed minus 8 is the difference of two squares. So when using the difference of two squares, we know that we can put that, once we find a and b, into this formula. We have a minus b multiplied by a squared plus ab plus b squared. And it's always good to remember your differences of your squares, the differences of your cubes, so that you'll know and have it handy. So how do we figure out what a is and what b is in this case? You would look at this, well, this is actually the formation it's in, is a cubed minus b cubed. So how do we figure out what a is and what b is? So we're going to take the cubed root of x cubed, and we know that x times x times x gives us x cubed, meaning that a is equal to x. Now we're going to take the cubed root of 8, and we know that that is 2 times 2 times 2, which gives us 8, and b is equal to 2. So now that we know what a is, then we know what b is. We're going to enter it into this formula. So what we have is x minus b, and we're adding that back into this. So we have x squared plus 2x plus 2 squared, which is x minus 2 multiplied by x squared multiplied by, well, 2x plus 4. So now what we have is x minus 2 multiplied by x squared plus 2x plus 4. And we're going to put that in our denominator all underneath our numerator. And we're going to see what we have left over to see what cancels. So we have x minus 2 over x minus 2 multiplied by x squared plus 2x plus 4. So what we have is x minus 2 divided by x minus 2 multiplied by x squared plus 2x plus 4. Now when we see things in this format, polynomials, we think we need to find two numbers that multiply to give us 4 and two numbers that add together to give us 2. Multiples of 4 would be 4 and 1 and 2 and 2. Well, we know that 2 times 2 gives us 4, but 2 times 2 does not give us 2. It gives us 4. So we know that this polynomial is not factorable. So this cancels and this cancels, which leaves us with our answer, which is 1 over x squared plus 2x plus 4. Here we're going to reduce to the lowest terms by factoring. Okay, so the first thing that we see is that we have two polynomials. We see that a is equal to 1, so all we have to do is figure out which two numbers multiply to give us 36 and which two numbers add together to give us a negative 12. And in the bottom polynomial, which two numbers multiply to give us a negative 18 and add together to give us a negative 3. So the first thing that we're going to do first, well, we're working with a squared minus 12a plus 6 divided by a squared minus 3a minus 18. So we're going to find the multiples of 36. Okay. We have 1 and 36. We have 2 and 18. 3 and 13. 4 and 9. And 6 and 6. Okay. So we see now that 6 times 6 equals 36. A negative 6 plus a negative 6 also gives us a negative 12. So those are the numbers that we're going to go with. So we have a minus 6 times a minus 6. Negative 6 plus a negative 6 is a negative 12, and a negative 6 times a negative 6 gives us a positive 36. So that checks out. Now we have our second polynomial, where we have to have two numbers that multiply to give us a negative 18 and two numbers that add together to give us a negative 3. Okay, and there we have 1 and 18, we have 2 and 9, and we have 3 and 6. So here we can see that a negative 6 times 3 gives us a negative 18, and a negative 6 plus 3 gives us a negative 3. So what did I say? I said a negative 6 times 3 gives us a negative 18, and a negative 6 plus 3 gives us a negative 3. So that means we're going to have a minus 6 and a plus 3. So here we see that the 6 is negative, so we're going to do a minus 6, and our 3 is positive. Whether we adding or whether we are multiplying, it's positive. So that's why it gets the plus. So here we see that we have factors that are similar, that are the same, that we can cancel out. And we have a minus 6 here and a minus 6 here. And that leaves us with a minus 6 divided by a plus 3. And that's our answer. So we're going to reduce this down to its lowest terms. And we're going to do that by using prime factorization. Now, I like prime factorization because it helps eliminate those careless mistakes, and you can visibly see what you have and what cancels out and what doesn't. So here we have 4 over 3 pi r cubed divided by 4 pi r squared. So we have our 4 over 3 times pi times r times r times r, divided by 4 times pi times r times r. So we see now that we have this pi cancel, these r's cancel, and those r's cancel. So we cancel out in pairs. And because we cancel in pairs, we see that we have one r that's left here and nothing's left under the bottom to cancel. So we have to leave that there. Also, I see that we have 4 divided by 3, or 4 over 3 divided by 4, which also equals 4 over 3 multiplied by 1 over 4. And we know that when we are dividing fractions, we know that we have to multiply by the reciprocal of the second fraction, which is why 4 became 1 over 4. So we're going to multiply straight across. 4 times 1 is 4. 3 times 4 is 12. And we can simplify. 4 goes into 4 one time. 4 goes into 12 3 times. So it simplifies into 1/3. So we have 1 times r divided by 3, which is equal to our answer, which is r over 3.